Alhamdulillah Rabbil Alameen. Wassalatu wassalam ala Rasulillah wa ala alihi wa sahabi wa sallim. This is another lesson. This is lesson 2 on our topic, hydrogen and its compounds. From the previous lesson, that is from lesson 1, we have looked at brief history about the discovery of hydrogen, its occurrence, its electronic configuration, its oxidation number. We have also looked at the laboratory preparation of hydrogen, the three basic commonly used methods for the preparation of hydrogen in the laboratory, which are the action of zinc on an acid, action of sodium on cold water, the action of iron on steam. Also, we have looked at the industrial preparation of these very important gas. The industrial preparation when we want to produce on a large scale. So, from brush process, that is from the water gas, using the water and coke as raw materials. Then from methane, we can produce this. Then from bioelectrolytic methods, we have emphasized that. We have also looked at how hydrogen is placed in the activity series, especially when it comes to reacting some metals with acids and water. What are the metals that can liberate hydrogen from acid or water when they react with it? So we have emphasized the fact that some metals are very reactive to the extent that when they react with water, they can release hydrogen. When they react with ordinary cold water, they can release hydrogen from it and they will form alkalis when that reaction comes to completion. Some, they are just moderately reactive. They can release hydrogen gas when they react with acid or water. So examples of such moderately reactive metals are magnesium, aluminum, zinc, and iron. So there are some that they will not show any reaction with acid or water. That was the last thing we discovered when we talked about the hydrogen and the activity series. No reaction with either cold water or steam. Metals like tin, lead, copper, mercury, gold, and silver, when they react with acid or water, they show no reaction. There will not be any liberation of hydrogen gas. Today we shall continue from where we stopped. We will talk about physical properties of hydrogen. Number 1, hydrogen is a colorless, odorless, and tasteless gas. You cannot see the color of hydrogen. You cannot give it this is the particular color hydrogen has. You cannot tell us its odor, just like fish has a kind of aromatic smell. So there are some gases like hydrogen sulfide, they smell like a rotten egg smell. Yes. So but hydrogen will not give you any odor. So it is tasteless as well. Number 2, it is neutral to moist litmus paper. Litmus paper can be red, can be blue. When you make it moist and you try to pass it in a gas jet that contains hydrogen, it doesn't show any reaction. Maybe red will change to blue or blue will change to no. It is neutral to it. That is hydrogen. It is relatively insoluble in water. Only 2 centimeter cube of it will dissolve in, let's say, about 100 centimeter cube. That's about 0.1 dm cube of water at standard temperature and pressure. Also, hydrogen as it has a very low boiling point of minus 253 degrees Celsius. Minus 253 degrees Celsius. These are a few of its physical properties. Then chemical properties of hydrogen now. If you want to explain the chemical properties of hydrogen, it can be explained by a tendency first to acquire the stable duplet electron configuration of helium. This can take place in 3 ways. Hydrogen can accept electrons to form hydride ion, that is H-. It can share its lone electrons, forming a covalent bond. hydrogen can also donate its lone electron to form positive hydrogen ion or proton. So these three things can take place before hydrogen reacts. So that is why we say that the chemical behavior of hydrogen can be explained by tendency to acquire the stable difference structure. So thus hydrogen can accept an electron from another atom to form negative hydride. Number 2, hydrogen can form a covalent bond by sharing its lone electron, the only electron it has, so to form a hydrogen molecule. Then it can donate its lone electron to form positive hydrogen ion, that is proton. So that is why you see hydrogen entering into coordinate bond formation with molecules that have lone pairs of electrons. For instance, molecules that have lone pairs of electrons, water has lone pairs of electrons, ammonia has lone pairs of electrons. So when hydrogen, when it donates its lone electron to such molecules, so for instance, if it is with water, so hydrogen ion will combine with water to form hydrozonium ion, that is H3O+. Then it is also possible that it combines with ammonia, so to form ammonium ion, that is NH4+. Now, moving forward, 2 basic headings will be used for chemical properties of hydrogen here, and some of the reactions will be shown. Hydrogen can undergo combination reactions. It can also undergo reduction reaction. Generally, hydrogen can react with metals to form hydrides, metal hydrides. So for instance, when hydrogen combines with metal in its combination reaction, as you can see here, it combines with sodium and it forms sodium hydride, being a very active metal. The same thing will take place for potassium or lithium or other very reactive metals like that. The hydrogen can also combine with oxygen to give us what? To give us H2O gas. That is steam what will be produced. Hydrogen can also combine with halogens, the group 7 elements. The group 7 elements, that is the halogen, the acid formers, Cl2 plus H2 giving us 2HCl, Br2 plus H2 giving us 2HBr. So these are a few of the combination reactions that hydrogen gas can undergo as part of its chemical reactions. Then hydrogen can behave as a reducing agent. Hydrogen is a strong reducing agent. It reduces the oxides of metals like copper oxide, lead oxide, iron oxide, zinc oxide to their respective metals. That is especially when they are heated in a stream of hydrogen gas. When copper oxide is heated in a stream of hydrogen gas, you are going to have copper metal being formed, and you're going to have H2O as a steam being released in that process. Or iron 2 iron 3 oxide, when it is passed in a stream of hydrogen gas, you're going to have iron, solid iron being released, and the steam will be released as a gas. So what has happened there? Looking at this reducing action of hydrogen here, this particular one, CuO plus H2 giving us Cu plus H2O. The Fe3O4 plus 3H2 giving us 2Fe plus 3H2O. What happened? Hydrogen has reduced copper 2 oxide to ordinary copper. So hydrogen is having as a reducing agent here. So in the other one, second reaction, the iron 2 iron 3 oxide has been reduced to ordinary ion by what? By hydrogen. So these are equations showing the reducing action of what? Of hydrogen. Moving forward, hydrogen as it is, it can hydrogen, it can be tested for. Yes. How do we test for hydrogen? This diagram is showing how hydrogen can be tested for in the laboratory. For the general test for hydrogen, what does it do? Hydrogen bonds with a pop sand. When a lighted splinter is inserted into its container, what does it mean? Looking at these diagrams, we have magnesium ribbon vinegar. Magnesium ribbon is a metal, vinegar is an acid. So we are going to have hydrogen gas being formed in the upper tube here. Then when you now take the upper tube aside, hydrogen being the fact that it is less dense than here, so it will stay up in the gas because it's collected by what? By upward delivery, that is downward displacement of here, being a lighter gas than here. So when it is inside this tube, as you can see at the right hand side here, take a lighted splinter towards it. What you are going to hear is a pop sound. Poof! So the pop sound is giving the fact that hydrogen gas is present in the reaction that took place between magnesium ribbon here and vinegar, between a metal and what? And an acid. So this is a metal. Magnesium is a metal that can displace hydrogen from its acid. So now a pop sound is a significant feature we see to know that hydrogen gas is present in a particular gas jar or tube. Now, use of hydrogen. Hydrogen is used in the manufacture of ammonia. It is used in the manufacture of hydrochloric acid and methanol. 2, it is used in the production of margarine. That is margarine for cooking or for toasting bread and the likes. It is used for filling balloon. That is number 3. Liquid hydrogen is used as a rocket fuel. As a rocket fuel to travel to space. Yes. The space travelers, the astronauts, if they want to fuel their rocket, so they can also use hydrogen gas. Number 5, it is used in oxy-hydrogen flame, which is about over 2000 degrees Celsius, used in melting metals. Actually, when you want to join metals together, you have to melt one part, melt the other part, then join them together. So the flame that comes out from the welder's instruments they use, to do their welding, such a flame can be oxy-hydrogen flame because it has a very high temperature, such a way that it can melt the gas. I mean, it can melt the metals. Moving forward, hydrogen has isotopes. Isotopes, they are atoms that have the same atomic number but different mass number. So hydrogen exists in 3 isotopic forms. Number 1 is hydrogen or proton. Number 2 is the heavy hydrogen or deuterium. Number 3 is tritium. So with their relative atomic masses as 1, 2, and 3 respectively. So these are the isotopes of hydrogen. They have the same atomic number of 1, but different mass numbers. For instance, this heavy hydrogen, deuterium now, when deuterium when deuterium reacts with oxygen, it can form an oxide, which is the D2O. This oxide is similar to water. Yes, it's similar to the H2O that is formed from the first hydrogen, which is the proton. So this heavy hydrogen, when it's reacted with oxygen, it forms heavy what? A compound known as heavy water. This heavy water is about 1.1 times even heavier than ordinary water that we have. So then the tritium is a radioactive isotope of hydrogen. So it's a radioactive isotope of hydrogen and it's rarely found in nature. It's rarely found. Now moving forward, hydrides. When we say hydrides, these are formed when hydrogen does what? What does hydrogen do? When hydrogen gains an electron, that is when you form a hydride. So it is possible that the alkaline and the alkaline earth metals like sodium and calcium, they can form ionic hydride with hydrogen. These hydrides that are formed, like sodium hydrides, like the calcium hydrides, so they are crystalline ionic solid. They are ionic solid, meaning that they have high melting point, they have high boiling point and high melting point. They have the properties of the ionic compounds, and they can conduct electricity when they are in molten form. So they readily react with water to form hydroxides. Yes, they form alkaline, and they can liberate hydrogen gas with that when they react with water. What do I mean? if you have, as we have here, so calcium hydride reacting with water, giving us calcium hydroxide, and hydrogen gas will be released. So compounds that are formed when a metal react with hydrogen are what we call the hydrides. As you can see here, it's not only group 1 and group 2 elements. I mean the alkaline and the alkaline metal that can react with hydrogen to give us hydride. The hydride which can easily react with water to give us alkaline or a base, and hydrogen gas will be released in that process. So we can also have group 3 elements like boron, aluminium. Yes, all these, they can also release hydrogen when the hydrides react with what? When the hydride react with water. But what actually do they form? Boron and aluminium, they form complex covalent hydrides. They form complex covalent hydrides. These covalent hydrides they form are very important reducing agents, especially in organic chemistry. Organic chemistry, we still talk about it. That is the chemistry of carbon compounds, which exclude the triisocarbonate and the likes. So when we're talking about the chemistry of carbon compounds, so it's a very important aspect of chemistry. So what am I saying? Boron and aluminium, when they react with hydrogen, they form covalent hydrides. These covalent hydrides, they are very good reducing agent, important reducing agents when it comes to what? When it comes to reactions in organic chemistry. For instance, LiAlH4, lithium tetrahydroaluminate 3 is a very good reducing agent. Then we also have sodium tetrahydroborate 3. It's also another important hydride of the group 3 metals. That is, when group 3 metals react with hydrogen, they form hydrides, and the hydrides are very good reducing agents that are used in organic chemistry. Besides that, most non-metallic elements like chlorine and nitrogen, they form simple covalent hydrides. So these are volatile compounds, unlike the other ones that are unique, that are not volatile. These ones are what? They are volatile compounds, and that they are gaseous at room temperature. So they are gaseous substances at what? At room temperature. For instance, we have HCl, that is the hydrogen chloride gas. We have ammonia gas. So they are examples of the hydrides that are formed when non-metals react with what? We have the hydrogen. So non-metals like chlorine and nitrogen. While other hydrides from non-metals like fluorine and oxygen, which can form hydrogen fluoride and H2 respectively, they are liquids. Why are they liquids? They are also hydrides of non-metals. They are not gases. They are liquids because in their molecules, they have extensive hydrogen bonding. When you have many hydrogen fluorides now, you have many hydrogen fluorides coming together. So they will not exist as a gas. They are going to exist as a molecule. So that is why they are liquid. The same thing applies to water. That is why water would prefer to exist in form of liquids than existing in form of what? In form of gaseous, because of the hydrogen bonding holding their molecules together. So we have been able to talk about hydrogen generally. So that is, we have been able to talk about its occurrence, electron configuration, oxidation number, about preparation. I've been able to talk about the industrial preparation, how hydrogen is placed in the activity series, and how some metals can displace hydrogen from its acid and water, how some others cannot do that. So that will guide us in production of what? Production of some compounds or some gases. So we have also looked at the physical and chemical properties of hydrogen. So we have also looked at the chemical reactions that hydrogen can undergo with some combination reactions, the reduction reactions that hydrogen can perform. Then we have also looked at the test that is very common to what? To hydrogen. Besides that, we have also looked at the uses, what we can use hydrogen to do. Yes, It's very essential to know what it can be used to do. We have looked at that. We have looked at the isotopes of hydrogen and the hydrides. On this note, we would like to call it a day. So we'll stop here on the hydrides. There are still more things to be said about compounds of hydrogen. That is when we get to hydrocarbons. When we're talking about the organic compounds. So I pray Allah subhanahu wa ta'ala grant all the understanding and bless our knowledge. These are little things, few things we can talk about as regards hydrogen now. I pray Allah bless us and give us a better understanding of it. So may Allah be with us. So I'll stop here for today. Wassalamu alaikum wa rahmatullahi wa barakatuh.